Hey everybody, this video is going to cover the engineering you need to think about when you're producing 3D parts. If you're just doing a prototype, that's one thing, but if you're going to use that part, it needs to be engineered. Okay, in this video we're going to talk about when you're using different materials and different design techniques and how to create a part that you're actually going to use. Sure, if you're using a 3D printer to do a prototype so you know if the parts fit and the shapes, but what happens when you're going to really use that part as a structural component in a design? So what I'm going to do here is share some of my testing and some of my thoughts. As you know, that 3D printers are basically melting a material and squirting it through a nozzle and putting it in layers. Those layers will make up an object. So this object right here is a piece of ABS impregnated with carbon fiber. If this was a solid piece, we could pretty much know what the behavior of the material is going to be. However, when we lay down a part with a 3D printer, there's a lot that goes on. So let's look at this little clip I did right here. Here you see my slicer program that I use to import my drawings that I've designed so I can put it into my 3D printer to create an object. So this right here is just a test object you're looking at. This was just for me to be able to put into the rig I've made so I can test when materials fail. But what I want to show you here is when you look at an object that's going to be 3D printed, okay, it's basically, if I zoom way in here, each one of these lines here is a melted piece of ABS that then is extruded or squirt out of the nozzle. So this is the pattern for the very first layer. If I go to the next layer, whoops, went too far. If I go to the next layer, well actually that jumped 2 layers, but no, that's 1 layer. So if I go to the next layer here, you can see that it's extruding in the other direction. And then it is extruding in a different direction, and then you'll notice right here it starts to build cavities inside it. And this is when you're building a part that's not going to be completely solid. So this part right here I set, if you look up here, the infill is set at 25% and my fill pattern is honeycomb. So only 25% of this will actually be a solid. I'm using a honeycomb design in the middle, not because I have any proof yet, but I know that it will structurally support the top and bottom of the print. Now I don't know pulling long ways if it creates any more strength yet. I haven't done enough testing. But if you look at my layers, my first 5 layers are solid, then I have the honeycomb, and then I have a top 5 layers. So if we go back and look, you can actually see how the 3D printer is going to build up all of these layers. But I really want you to think about the direction that this is all going, and keep in mind the height-wise of this. When a 3D printer lays down each layer, it's only using the melted ABS or whatever material I'm using to stick to the next layer, so it's not completely infused. So the only strength you have in vertical layers is the adhesion of the material sticking as it's laid down. However, when you think about the strength long ways, this is continuously melted ABS or whatever material. So lengthwise, this is going to be incredibly strong. But thickness-wise, if you were to ever pull on, if you were to ever print something vertically where you were relying on the layers for strength, it's just not very good. It's probably 1/50th the strength, and I'm going to do some testing on that in the future too. But this video is to show how strong these parts really are being with different materials and how you have to think about it when you're engineering the part. So on this part right here, you're pretty much going to think in your mind, okay, this is only going to be for a load that's putting this in tension, okay? Is talk about What happens if you have parts where you have angles? Now on this video right here, I want you to think about when this is printing lengthwise, you're going to see a lot of strength, but the vertical parts of these are done in layers. So lengthwise there's strength, but vertical wise here there is not much strength. Okay, so if I were going to design a part that's shaped like this T here, or I'm shaped like some of these L shapes here, I would not print it like this on the bed. Okay, just lengthwise here you got a lot of strength, but vertically you don't. So what I would need to do is tilt these on their sides and figure out how to make it. But just like I did on the other one, I would go inside here first. I would look at, what the infill is going to be, what the strength's going to be, my density. Do I want it to be 25%? See here, you can see the honeycomb, and this is showing all the cavities that would be in the part. So if you think about the vertical part, or the vertical part of this part, see, wouldn't be strong. See here, lengthwise, this is all going to be as strong as a part in tension. But as I build it up, all of this here, its strength is only relying on the layers that adhere to each other, and it's not that strong. It's like 1/20th or 1/50th of the strength that it would be lengthwise, because the way the extruder melts the material and then lays the layers on. I hope that makes a lot of sense to everybody watching, because if you think about a piece of plastic that is extruded lengthwise and you pull on it, it's strong. But if you took two pieces of plastic and stuck them together, they're only going to be as strong as whatever the material is that's sticking them together. So all these parts in theory would be tilted on their sides. That way, as the extruder extrudes them, it's extruding one long piece along both axes on the printing surface. So to really build these parts right, you would lay them on their sides. Okay? Hope that makes sense. Now what we're going to see here is 3 initial videos that's going to show the testing of these parts. So I hope you enjoy what you just saw there. I've learned a lot with the testing, and I've got a lot more parts that I've printed that I'm going to be testing too, because I really want to know how this is going to hold up as I finish the C-130. C-130 has some parts in the landing gear I still need to make, and the spinners. And I've already 3D printed a spinner, and actually this was the very first prototype, but the second one I printed was with the carbon fiber, the ABS that's impregnated with carbon fiber. It's already on a test jig. I just don't have a 1032 long enough to test it to hold the spinner on. One of the things I've learned, and I don't know if it's because of a lot of videos out there are dated and carbon fiber ABS is new, and you know the whole 3D printer thing is less than 10 years old. So I think one of the things is people think that when they hear carbon fiber, they think it's going to be a lot stronger. And I think the reason people like carbon fiber is the look. Because you can sand the carbon fiber down and then put a clear coat on it, and it looks really cool. Okay? But as far as strength versus weight, there's not that much of a trade-off. The carbon fiber is lighter. Okay? But I think if I did some algebra, you'd see you're losing the amount of strength through the weight, or the density. Okay, so the ABS is the strongest without a doubt, as you saw from this video. The carbon fiber is really neat, but it's nowhere near as strong. And the PETG is really neat, but I'm not a real fan of it because it gets all over my nozzle. By far the ABS is the easiest I've had to print. I don't know if this is also because of things have been out in the internet so long, but I've read so much about ABS having bad fumes, and that's the reason people don't want to use it. And that's the reason people want to use the PETG. I don't find that at all. I've done a lot of ABS, both with the carbon fiber, the ABS impregnated carbon fiber, and the regular ABS, this stuff, and I don't notice any fumes. Once in a while I notice a little bit of an odor with the carbon fiber, but I think that's just my nozzle being hot and the bed being hot. So right now ABS is my favorite. Carbon fiber is very cool. It's very easy to print. ABS is very easy to print. Adhesion to my bed is basically wiping my bed down with a little bit of alcohol. I did get that Captain tape, and it is the neatest thing since sliced bread. I've actually done 20 pulls off my heated bed without having any problems to the bed. Okay, no delamination, nothing coming up. The Captain tape is the coolest thing if you ever put it down on your bed. So I hope you love my videos. Keep the emails coming. Hope you find this beneficial. I'm going to be traveling a little bit for work, but then I'm going to get into testing the spinner for the C-130. I'm going to put at least 50 minutes, hopefully the 8,500 RPM range on that spinner to see if there's any fatigue problems. The prop should never exceed 6,500 in flight. So I think I'm really close to figuring out how to 3D print these spinners. When I balanced this one, it virtually came out perfect. I didn't have to do anything. So I guess the way the 3D printer is extruding and doing everything down to the 100th of a millimeter, these are almost, they're perfect. So this one didn't need virtually any balancing. A couple of coats, and I can't even see it. I took a paintbrush and put a couple of coats of black paint on the inside here to balance it, and that's all it took to balance this spinner. So, hope you enjoy my videos. Keep the emails coming, and have a wonderful day.